All right, welcome to RC Circuits. We're going to call this one the capacitor charge formula. So here's a basic RC circuit with a series switch included. And what's going to happen is we're going to close that switch and that cap's going to start charging. And here's our VC or cap charge formula. VC is equal to V final minus the quantity V final minus V initial e to the negative time over RC, where RC is also equal to, or sometimes called, tau. Okay, so we're interested in, finding out how much time it takes to charge up this capacitor, how it charges, and where we're at in time. If we just let this switch close, eventually it's going to charge up. That cap's going to charge up to the voltage of the DC supply. But we want to know how fast it charges up, or at a particular moment in time where that capacitor would be. So we can rewrite our capacitor charge formula in terms of percentage and time versus tau. And if we do that and we say, okay, well, our time, let's make our time equal to 1 tau. So RC and time are equal. We get the formula equal that written out like we have them here. So our final is going to be 100% of the voltage. Our initial 0, and you see that we get that e to the raised to the negative 1 over 1, which gives us e of negative 1. So that is time equals 1 tau. And if we do all the math, we find out that our VC should be 63.2% of our V final if we have a time equal to 1 tau. So this slide is almost identical to the previous one. The only difference is we've now increased time to 2 tau. And all the math is the same. We've just now got that e to the minus 2. And we see that VC should charge up to 86.46% of V final. Same thing, we've just now increased to time equal to 3 tau. We see that we get a VC of 95.02% of V final. Here's time equal to 4 tau. And we can see that VC is 98.168% of V final. And finally, we've got 5 tau. VC equaled 99.326% of V final. Now, this is where we say that the capacitor is fully charged. 5 tau equals a fully charged capacitor. And the circuit now could also be said that it's all stable. Everything's stabilized. So here's our data. We've got tau versus percent of charge of the capacitor voltage. And we can see at 5 tau, we're basically charged all the way up. I've built a graph, an Excel graph, that goes all the way out to 10 tau, and you just see that that capacitor is fully charged at that point. Now, if you wanted to, you could go in there and graph the points in between 1 tau and 2 tau, or graph it all at like 0.25, 0.5, 0.75, and then 1, and then all the way through, and that'll get that curve a little bit smoothed out. You can see those points there. You could up that resolution by graphing more data points. But the intent of this is to show the relationship of tau and time, and that 5 tau gets us a fully charged capacitor.